Hi, so we'll be starting off with coordinate geometry. Coordinate geometry is nothing but a combination of algebra and geometry. What usually happens is that we have a small plane, a sheet of paper, or any place in the world or any physical space. You can divide it in a plane meaning that it can be divided in two axes. It can also be divided in three axes because it's a real world and everything that we see is in 3D. There's hardly anything that is in 2D. So, for the ease of understanding and for our syllabus as well, we'll be dividing the world into two axes. One is the x-axis, the one which is horizontal, and the one which is vertical, that is the y-axis. So what does it actually mean? It means that there is a center of the paper or of a wall or anywhere which is called the origin, and this is the place of beginning where everything starts from. And I need to measure that if I am walking from my origin till this point, let's say this point is A, it has coordinates as well. What do we mean by coordinates? By coordinates means that if we wish to move in the horizontal direction, there would be a coordinate of x attached to it. And if we wish to move in a vertical direction, then we'll have a coordinate of y attached to it. If we wish to move in both vertical and horizontal direction, in a trajectory motion or in a slanting way, at an angle with respect to the x-axis or at an angle with respect to the y-axis, at that time, then the alphabet A or the point A has two coordinates, x and y. As we move on the earth, we get longitudes and latitudes. So moving on a plane or moving on a piece of paper will involve two coordinates, which are the x coordinates and the y coordinates. Okay, the x coordinate and the y coordinate. So any point which is lying on the x axis is going to have a zero coordinate of for y, and any point which is lying on the y axis will have a zero coordinate for x. Okay, so each and every line is represented in the form of an equation. This is very important to understand. Okay, we've already learned about equations in two variables and simple equations in one variables as well. So each and every line that is drawn, each and every line that is drawn is represented with the help of an equation. That equation in the most basic form can be called as x upon a plus y upon b is equal to 1. Okay, that equation can be called x by a plus y by b is equal to 1. So with the help of this equation, you can find out, or you can draw the line in a plane. When I mean to say that there are two equations or there are two lines which are there, so I can say that there is another equation with x upon p plus y upon q being equal to 1. So this is another form of an equation. Whenever we are trying to find a common point between two lines, at that time we will have to find out the solution of the equation. When I say solution of the equations, that I mean to say that you'll have to find out the value of x and y. That is when you'll be able to find out the intersecting point of two lines. Okay, so that is the solution of the equation. Let me talk about, if two equations of lines are given, then what do we actually expect from it? So the most basic form is the intercept form of line. Okay, this is called the intercept form of line. On the y-axis and here on the x-axis, let's assume that this line is available. Okay, this line is available. I can say that m or y is equal to mx plus b, where m is nothing but the slope of the line and b is the y intercept. What does y intercept mean? Y intercept means that the line the line which is in question, okay, this is the x-axis, this is the y-axis, and this is the line in question. Let's call this line as AB. Let's call it a line segment. Okay, it's AB. So this particular line segment in question, it is touching the y-axis at a point which is 0 comma b, and this, the value of b is nothing but the y intercept. Okay, this is going to become really interesting and really fun once you start solving the questions. Before that, you will just have to mug up whatever I'm talking about. So y is equal to mx plus b is the slope intercept form of a line. And when we have the line in this sort of a manner where it is cutting both the x-axis and the y-axis, it is definitely cutting the x-axis and the y-axis in this situation as well. But here it is more clear to watch. So here I would say that x upon a plus y upon b is equal to 1. Here we can very clearly see that there is something called a comma 0, which is a point which is being created after the line hits x-axis. So a is the x-intercept. That is why it is being written in the denominator of x. Okay. Similarly, b over here is the y-intercept. Why is it called the y-intercept? Intercept because it is touching the y-axis at a point when it is being extended. Okay. So this is the simple intercept form, and this form of line y is equal to mx plus c is called the slope intercept form. Okay, this is the intercept form, this is the slope intercept form. Also, two slopes of m1 and m2 would be equal when the lines are parallel. Similarly, m1 multiplied by m2 would be equal to -1 when the lines are perpendicular. Okay, this is for parallel, this is for perpendicular. Okay, parallel and perpendicular. So most of the entire coordinate geometry is summed up in this situation. Now the only things that are left to understand are the distance formulas, the section formula, and the area of the triangle. Yeah, that's pretty much. Distance formula, section formula, and area of the triangle. Okay, these are the only three main topics which are left. Now, talking about the graphs of equations, this and this intersect at point P, A, comma B. Then what is the value of a square plus b square minus ab whole upon a square minus b square plus ab? Okay, so this is the question that we are facing. In such a question, you have to straighten up the equations that are written. Okay, 30x minus 20y is equal to 2. Similarly, 11x minus 5y is equal to minus 61. In this situation, I would multiply it by 4 and would now solve it. It would be 3x minus 20y is equal to 2. Similarly, 44x minus 20y is equal to minus 244. I'll be subtracting both of them from each other. That would create a plus sign here. It will also create a plus sign here. The value of this would be 41x and that too of minus, which would be equal to 2. How much would that be? This would become a plus 246. So the value of x that I would get from here would be equal to 6 units. If I put that back in the equation, that is 3 6 is 18x. So x is no more there. 18 minus 20y is equal to 2. And just a moment. The value of x is not 6. The value of x is minus 6. Yeah, yeah. The value of x is minus 6. This is minus 18. It's going to go the other way. So if the value of x is equal to minus 6, this minus 18 would go the other way, and this minus 20y would convert to 20, and the value of y would become minus 1. So I have the value of x is equal to minus 6 and y is equal to minus 1. What happens here is this is the value of a and this is the value of b, because I have solved the two equations and found out the common point. It is saying that the common point is equal to p, a and b. The point a in the brackets a comma b. So this is a comma b. Now I will put these values in the equation and try to figure out my solution. Minus 6 square is 36. Again, minus 6 square is 36. A plus sign and a 1. A plus sign and a 1 and a minus sign with a 6. A minus sign and a 1 with a plus sign and a 6. What do I get out of this? This becomes 31 and this becomes 41. So 31 by 41 is my answer. This is the answer that I was looking for. Okay, I hope everybody could get it. Now I'll move to the next question. Yep. So the graph of a linear equation, this and this intersect at a point called a comma 4. What is the value of k? What is the value of k in the equation? If there is an intersection of point available which is at a comma 4, that means I can put in the value of y equal to 4, which would give me the value of x as a coefficient or x as a coordinate. Okay, so I would get here at 4x minus 2 multiplied by 4 being equal to 1. This thing would go on the other side and it would create that the value of 9 by 4, the value of x is equal to 9 by 4. Now I'll put this thing back to this equation and I would say that 4 multiplied by 9 by 4 plus k multiplied by 4, which is the value of y I've already talked about, is equal to 2. So this is 9. 9 would go there. This would become minus 7. So 4k is equal to minus 7. So the value of k is equal to minus 7 by 4. Okay. So the value of k is equal to minus 7 by 4. Got it? Got it? I hope you are able to understand things very well. Right? Let's move on. Okay. The graph of the equation, this and this intersect at point P, which also lies on the graph of the equation. The four equations are given to us. So what would we do? We would first try to find out the intersecting point P. Once we have the intersecting point P, we would use that point P and put the values of its coordinates, which would be x and y, into all these equations. Wherever we find the equation to be satisfying or the output to be 0, that is when that is what would be my final answer. Okay, let me not waste any time and just write things down. 7x plus 11y is equal to 3, and I have 8x here and y doesn't have a coefficient, so let me multiply the entire situation by 8 or the entire equation by 11, right? So I would get 88x plus 11y being equal to 145, right? I'll subtract everything from everything. So this would be 142, this would be 81x, and the y thing would have get cancelled out. The value of x is equal to 2, or am I wrong here? It should have been 162. This is not 150, this is 165. This is 162 now, right? So 81 ones are 81 twos are. So the value of x is equal to 2. I have one of the coordinates available with me. I'll put that down in the second equation. Why do I put down things most of the time in the second equation? Because that is much easier for me. You can also find out which equation is easier. So you'll be able to figure out. If the value of x is equal to 2, putting it back, I would get 16 plus y being equal to 15. So the value of y is equal to minus 1. I have x with me, I have y with me. I have x with me, I have y with me. Now I need to have 2 comma minus 1, which is being satisfied in any of the equations here. I'll quickly put 2 and minus 1 here. 2 is equal to 4 and this is minus 1. This is coming out to be 3. This is not equal to 2. Again here, 2 2s are 4. 4 plus 1 is equal to 5. This is not equal to 1. Then here I have 2 3s are 6 minus 5, which is equal to plus 1, and these two are matching. So the line which is also passing through the point of intersection of the two given lines has the equation 3x plus 5y is equal to 1. Okay, this was the answer that I was looking for. Got it? Let's move on. Now, so after understanding the basics of coordinate geometry in the past 3 or 4 slides, now we have a concept. In coordinate geometry, you'll have multiple concepts coming up, and the concepts are very very simple. So you won't have to worry about anything. Okay, that's a promise from my side, or rather, that's a promise from the side of coordinate geometry that there are not very tough concepts. Yes, there are multiple concepts, but they are not very very tough. So what happens is that I've already told you that whenever two lines are drawn in a plane, they can have multiple they can have multiple equations involved with it. And whenever they are in a plane, there are three situations that can occur. Either both the lines are overlapping each other. For the sake of convenience, I'm showing that one line is over the other line. Okay, the lines can be parallel to each other, which and they would never meet, right? Parallel lines are going to be equidistant from each other and they are never going to meet. And thirdly, the lines would be crossing each other or touching each other at one point. A line cannot touch the other line at more than 1 points. At when I say at more than one, two or three, no, not possible. Either it would meet at 1 point or it would meet at all points. Okay, when they are superimposing or when they are on top of each other, at that time only they would meet at all points, else they can only meet at 1 point or no meeting or complete meeting. Okay, so these are the three concepts which I am presenting in front of you. So we have line 1 here, we have the equation of line 1 here, we have line 2 here. Let me help you understand and help you read what this equation talks about. When I say a1x plus b1y is equal to, let me assume that it is minus c minus c1. So what is happening here is that we have a coordinate plane. This is the x axis and this is the y axis, and in this particular coordinate plane this line is drawn. Now you would ask me, how can I plot this line? The way or the route to plot this line is you have to take up different values of x and y. You may put and you have to let's say we are only going to try to find out the values of y by putting x equal to 0 or by putting x equal to any number. So you will get different values of y, you'll get different values of x. You have to couple up both of them and then plot them on the graph. An easier way to do that is to find out or to put the intercept form of line. Whenever I talk about the intercept form of line, I need to have the coefficient of x-axis and y-axis equal to 1. That means I have to find out the value of 1x, 1y. For that particular thing, I would divide the entire equation by minus c. That would leave me with a 1 over here. When I divide by minus c, I can write this as minus c by a, and I can write the other one as minus c by b. Or this can be a1, this can be b1, this can be c1, and this again can be c1. So in this particular equation, I can say that the x-intercept is minus c by a and the y-intercept is minus c by b. Let's assume this is the x-intercept, this is the y-intercept. When I join these two lines together, when I join these 2 points together, that is when I can find out the equation of the line. That is when I can find out the equation of the line, or I can find out the direction where the line is actually plotting. So with the help of these components of x-intercept and y-intercept, I can plot the line on the graph. So what are we actually doing here? We are trying to figure out, without even drawing the line, if the lines are parallel, if the lines are superimposing on each other, and if the lines are touching each other once or intersecting once. So these are the three situations which I have. This is the first situation, this is the second situation, and this is the third situation. In the first situation, if all the coefficients of x, y, as well as the constant terms are equal in proportion, not in absolute terms, but in proportion. If they are equal in proportion, at that time I can easily say that the lines are overlapping and there are infinitely many solutions. Okay, there are infinitely many points where they can touch each other, as I talked about here. Secondly, if I talk about a1 upon a2 being equal to b1 upon b2 not being equal to c1 upon c2, at that time I can say that the lines are parallel and they would never meet each other. They would never meet each other. That is a situation when no solution occurs. Got it? And thirdly, if I say that a1 upon a2 is not equal to b1 upon b2, but b1 upon b2 is equal to c1 upon c2, at that time we would have one solution. We would have one solution. In one of the previous slides, I taught you how to find out the solution of two lines. When I say I'm trying to find out the solution of two lines, that means I'm trying to find out the x and the y coordinates of the point where they meet up. The x or and the y coordinates of where they meet up. So the solution of two lines together is equal to the point where they are meeting, which would be equal to some x coordinate and some y coordinate. And in that situation, I need not solve the lines. I can easily say that if b1 upon b2 is equal to c1 upon c2, that means there must be one solution. Okay, there must be one solution. I hope this is clear. Let me take you to the questions now. So if two lines 3x, 4y, 16 is equal to 16, 6x plus ky is equal to 19 have a unique solution, then find out the value of k. I would take you back to the previous equation, and we are talking about one solution. We are talking about one solution. In one solution, I can see the third property comes into play. The third property says that b1 upon b2 is equal to c1 upon c2. As simple as that. The coefficient of y is equal to b. In the first equation, I will call it b1. So the coefficient of y is 4. In the second equation, this is going to be b, but this is the second equation, that is why it is b2. So the coefficient is going to be k. This is going to be equal to 16, which is the constant value of the first equation, and this is going to be the 19, which is c2, or the constant value of the second equation. This is going to come as 19. Now from here, I can find out the value of k as 19 into 4 whole upon 16, which is also equal to 19 by 4. For anybody who doesn't understand the concept, it is going to be a tough point. It is going to be a tough point for you to move forward. So remember this entire situation in your mind. Got it? Let's move on. Okay. So distance of point x equal to y from origin is x square plus y square, and the distance between 2 points p x1 x2 and q x1 x2 is equal to x2 minus x1 and y2 minus y1. Let me quickly explain it with the help of a graph. Yeah. So I have these two. This is my basically x-axis and y-axis. Here is the x-axis and here is the y-axis. Now, here is the origin, which is called 0, 0. Let's assume my point is somewhere here in the air, and the coordinates of my point are x and y. This is point A and this is point O. It is a convention that we call all the origin points as O. Now I need to find out the distance from center to the other side. For that, I would use the Pythagoras theorem. And if I use the Pythagoras theorem, what do I get? The gap from the origin to the point where my point A drops its intercept on the x-axis, the gap is x. The point from where my point A drops its y-intercept is equal to y. So this is equal to y. This length is equal to y. The vertical length is equal to y. I'll show you. The vertical length is equal to y. The horizontal length is equal to x. This is 90 degrees. So I'll use the simple Pythagoras theorem. The Pythagoras theorem says that we need to find out the length of the hypotenuse. We need to find out the length of the hypotenuse. The length of the hypotenuse is equal to the square of the perpendicular and the square of the height. So perpendicular and height, which is equal to x square plus y square. This is going to be equal to the height, or the total, or the hypotenuse, which is the total distance between 0 and A, or between O and A. So this is how the formula got derived, right? This is how the formula got derived. Got it. So I believe I have also taught you the derivation of this formula, which might not be really required for the exam. Similarly, this is a point. The only difference between this formula and this formula is that x1 is equal to 0 and y1 is also equal to 0 when we are talking about the origin. So the exact derivation of the formula or the exact output of the formula is given here itself. You can memorize it as it is for the exam. Okay. Moving to the question. 2 points lie in a plane and we have to find out the distance between them. Let me quickly grab x1, y1 and x2, y2 with me. X1 is 6, y1 is 3, x2 is 4, and y2 is equal to 5. So uh, the answer is x2 minus x1, which is equal to minus 2 whole square, plus y2 minus y1, which is equal to 2 whole square, and the root is going to have minus 2 square is 4, plus 2 square is also 4. It's going to have root 8. Root 8 is nothing but 2 root 2, which is my final answer. Okay, the answer is 2 root 2, which is my final answer. I hope everybody could understand it. Let me move again. Let me move forward again. So what are we talking about over here? Now there can be situations when, again, in this coordinate plane, you might get 3 lines or you might get 2 lines, including one or even both the axes. Let's assume if this line is given to you. Let's assume this line is given to you and it says that whatever area that is coming between the line and the coordinate axis, you need to find out what is the measurement of that area. What is the measurement of that area? In that case, this is a simple right angle triangle that you can see. I'll quickly change the color of the pen. Okay, this is the right angle triangle which you can see, right? And you need to find out the area of this triangle. This is the right angle triangle. So you can simply find out the area by applying half into base into height. You can simply do that by applying half into base into height. This is not a problem at all. So that is how we'll be functioning ahead. Okay. In the upcoming questions, there would be situations where you would get 2 lines. Let's assume this is one line and this is another line. Now it will ask you to find out the area which is common to both the lines, which is this area. Similarly, we'll do the same thing. We'll try to find out the height and we'll try to find out the length of the base. We'll again apply half into base into height to find out our final answers. Got it? I hope it is good enough. I'll be moving to the question now. So yes, the question comes here. It says, what is the area in square units of the triangle enclosed by the graphs this, and the x-axis? So we have 2 equations and 1 x-axis. So the x-axis is going to lie here, starting from this 0 point till infinity. So we'll be considering this line to be the third line. Talking about these 2 lines, what happens is we want the line to be in intercept form. So x by a plus y by b is equal to 1. This is going to be the intercept form. From this, we can find out where the line touches the x-axis through the x-intercept and where the line touches the y-axis through the y-intercept. Okay, so converting this equation into the intercept form equation, I can say that x by 3 plus y by 3 is equal to 1. Similarly, converting this also into the slope intercept or the intercept form only, this would come out as x by 6 plus y upon 12 by 5, or simply 2.4 being equal to 1. So we have two equations. We have two equations with us, and here we also have the x-axis with us. Now strictly talking about how we'll be approaching things forward. You can mark x intercept as 3 for this line and y intercept as 3 for this line. So the second equation is satisfied and I can easily draw the second line. Now talking about the first line, the x intercept is sitting at 6, the y intercept is sitting at 2.4. So 2.4 lies somewhere here. I'll use a different pen for the second line. Yeah, so I can draw the second line like this. And here the area which is under consideration is falling in this light blue area. This shaded region is the area which we need to find out, the square units basically. Okay, so from here I can easily see, I'll change the pen color one more time. Here we can easily see that for finding out the area of this particular triangle, we need to have the length of the base. The length of the base is visible as 3 units. We also need to have the height now. The height is this line. To find out the height, we need to have the y-axis length for the point where these two lines are meeting up. As I've already told you, whenever lines meet up together, you have to solve the equation and get the coordinates of x and y. You have to solve the equation and get the coordinates of x and y. So we'll be doing the same thing over here. We'll be solving the two equations. The first one being 2x plus 5y is equal to 3, and the second being x plus y is equal to, sorry, this is 12. Second being x plus y is equal to 3. So for x plus y equal to 3, I need to get the value of y. Okay, so for that I will eliminate x. So I'll multiply this entire equation with 2. When I multiply the entire equation with 2, I get 2x plus 2y being equal to 6. And when I subtract both the equations, the x gets cancelled out and I am left with 3y being equal to 6 and the value of y being equal to 2. Okay, and the value of y being equal to 2. So I can easily say that the coordinates of this point where both are meeting is x and 2. Why did I leave it at x? Because I did not need it. I have 2, which is my height, which is sufficient for me. I'll apply the same formula of half into base into height. The base is of length 3 units. I picked it up from here. And the height is of 2 units, which I picked up from here. Okay. So half into 3 into 2, I get the value as half square units as my final area, which is my answer. Okay. I hope you're able to understand that the concepts are very easy to understand and you just need to apply them. Okay. It won't take you very long to understand the entire chapter. Right? I'll move on. Now, there is something called section formula. What happens in section formula is that there are 2 points. The first one being A here and the second one being B here. Right? We have the point A and point B. They together are forming a simple line segment. In this line segment, we have a point C which is falling somewhere in the middle. Okay, be it a little more towards A and a little away from B. It can be any situation. So whenever we need to find out the coordinates of C, a point which is lying somewhere in the middle, and it is dividing the entire line segment into two halves, into two parts, where m is to n is the length ratio. So for that particular reason, we will have to use this formula. M x2 plus n x1 whole upon m plus n would become the x coordinates. N m y2 plus n y1 whole upon m plus n would become the y coordinates. Okay, this is something which you need to remember. Also whenever we have the coordinate axis over here, and a line follows a certain pattern. Let's assume this is the pattern which a line is following. So here we have point x1 y1 and here we have the point x2 y2. Okay, let's call this point A, let's call this point B. Now there would be a certain angle that the line is forming with the x-axis. This situation is for sure that the line would definitely cut the x-axis or y-axis once it is extended. Had I said that this line is present over here, then you would have asked me, this line is not even touching the x-axis. How can you even imagine for it to have an angle with x-axis? So my answer to that would be that once the line is extended, it is definitely going to hit the x-axis somewhere. So that angle which a line makes with the x-axis is called the slope of the line. Okay, it is called the slope of the line. And the slope of the line can be defined as m which is equal to delta y whole upon delta x. What do we mean by the term delta? Delta means the difference. Delta means the difference between the coordinates of y. Similarly, delta x means the difference of coordinates between x. Okay. Delta y means difference of coordinates of y, and delta x means difference of coordinates of x. So what happens in difference of coordinates of y? The difference of coordinates of y means the difference of y2 minus y1. This could have also been written in an absolute bracket. Why do I use the absolute bracket? The reason is the slope cannot be in negative in nature. Why is that so? Because we hardly find any quadrant where the value of tan is negative. So the slope cannot be negative in nature. Whole divided by the changes of y of x2 minus x1. So delta x is equal to x2 minus x1, delta y is equal to y2 minus y1. It could have been y1 minus y2 as well, but just for you to know and to help you out, because in a previous situation I'll show you where we've been, yeah, in the distance formulas also we are always using y2 minus y1 and x2 minus x1. So for the ease of convenience, I'm using the same y2 minus y1. So the slope is nothing but y2 minus y1 whole upon x2 minus x1. There is also called something the slope intercept form. The slope intercept form, I would be explaining it in the upcoming slides, but I'll quickly talk about it. The slope intercept form is called y is equal to mx plus c being the constant, m being the slope. This constant is also the x intercept. This constant is also the x intercept. And when you put in all these lines into picture, that is when you get the slope intercept form. Also, if two lines are running parallel, that means they have the same angle with the x-axis. That is why m1 would be equal to m2 when lines are parallel in nature. Similarly, if m1 is multiplied by m2 and we get a value of -1, that means the lines are perpendicular. That means the lines are at 90 degrees with each other. Okay, I've taught you almost everything about the slope intercept form as well as the internal section formula. And there is a concept of external section formula as well, that the line is out, that the point is outside. In in that situation, all the signs of plus would convert themselves into minus. Okay, in that situation, all the signs of plus would convert themselves into minus. That is the only legit point. Okay, when I talk about external section, I'll draw a dotted line here and I would say x comma y, this one being equal to mx2 minus nx1 whole upon m minus n. Okay, so this is the x. You can similarly find out the value of y as well. Okay, I'll move on. So in what ratio does the point -4, 6 divide the line segment joining points A and B here? So I have -6, 10 at one end. I have 3, -8 at the other end. Now there is a point M and there is a point N. So there is a ratio M and there is a ratio N. M is to N is the ratio. M is to N is the ratio in which the line is being divided by the point -4, 6. We are using the same formula that we talked about over here. Okay. So we'll be using this mx2. mx2 is 3m plus nx1 plus nx1 is -6n whole upon m plus n. This entire situation is equal to -4. Similarly, when we talk about y is equal to 6, which is going to be equal to -8m -8m plus 10n whole upon m plus n. So in such a situation, what do we have to do is, so what would we actually do here? We would now find out the value of m plus n using this entire equation. Okay, we'll find out the value of m plus n using this entire equation. If I equate the value of m plus n from both the equations, I'll at least be able to find out the relationship between m and n, right? We'll be able to find out m upon n. I think that is what we need to find. We need to find out m upon n. So I'll keep m plus n being equal to 3m minus 6n, 3m minus 6n whole upon minus 4 being equal to 10n minus 8m whole upon 6. So this is going to be 2, rather minus 2, and this is going to be 3. This is minus 2 and 3. The 3 is going to multiply there, 18m. No, this is going to be 9m minus 18n being equal to 16m minus 10n. So this would come here, this would come out as 7m, right? And this would go there as, is there a fault? No, I don't think so there's a fault. Just let me see. 9m, 18n, and the minus 2 being multiplied there gives me an 8n, and minus, this is not 10, this is 20. This is 20. The 20 goes there and it gives me 2n. So from here I can find out the value of m over n, which is equal to 2 by 7, which is equal to 2 by 7, and this is the final value which I was looking for. Okay, so 2 is to 7 is the final answer. Moving ahead. Now, the equation of a straight line on a point 3 comma minus 5 and slope 2 is what? So this is the slope intercept form, or this is the slope intercept form which I was talking about. Okay, so I'm talking about y is equal to mx plus c. Y is equal to mx plus c. The value of m is given as 2. The value of c is something which we need to find out. So the intermediary form which I have with me is y is equal to 2x plus c. If I find out the value of c, that is when my equation gets completed. So how would that happen? I would have to put the value of 3 and minus 5 in this equation. If any point lies on the straight line, it would satisfy its equation. Always remember this. If any point lies on the line, it would satisfy its equation. Satisfy its equation means it would bring down the equation to 0. So I'll put the 3 in the x side. This is 6, and I would put minus 5 in the y side, which is minus 5, and this being equal to c. So c is nothing but equal to minus 11. I found out the value of c. I already have the value of m. So in the formula y is equal to mx plus c, I can say that c is equal to minus 11 and m is equal to simply 2. So the value of y is equal to 2x minus 11. The value of y is equal to 2x minus 11. Got it? So this is the equation that I was looking for. The equation of a straight line on a point 3 comma minus 5 and slope 2 is this. If I rewrite it, I rejuggle it, the value is going to be 2x minus y minus 11 being equal to 0. Okay, this is the equation of the line on a straight line which has this particular point there, and it also has its slope available. Right? Got it? Let's move ahead. Now, when we are talking about reflection of a point, this question has appeared multiple times in the examination. Whenever we talk about reflection of a point with respect to the origin, what do we mean by that? If I'm talking about 2 is to 2, if I'm talking about 2 comma 2, okay, this is the point 2 comma 2. I've written y by mistake. This is 2 comma 2. This is the point I'm talking about. If my point is going in this direction, if it is going in the flying direction, it would go back here and it would reach here in terms of a mirror. Why? Because whenever I place a mirror on the origin, the mirror is placed in the vertical format, in this tilted format, okay? Because everything that is there would be visible at the back of it. That is why whenever the mirror is placed on the origin, it is placed in this angle, okay? A 45-degree angle, or rather a 135-degree angle. That is how the mirror image is formed. So the mirror image which I would find for something which is across the origin, okay, which is across the origin, that is when the signs would change, okay? The signs would change. But if I talk about a mirror image which is with respect to the x-axis, a mirror image which is with respect to the x-axis, that means the mirror is lying somewhere here. The mirror is lying somewhere here on the x-axis. At that time, the distance between the x-axis and the mirror would be equated in the opposite direction as well, and I would get the coordinates as, this is the point where the new image would be formed, and I would get the coordinates as the same positive x but a negative y. The same positive x but a negative y. Got it? But now if I talk about there being a being an image along the y-axis, so starting from the y-axis, we'll measure the distance till the point and we'll bring it back to the other side of it. So the x coordinates would now change to -2 and the y coordinates would remain in place. So this is according to y-axis mirror, this is according to the x-axis mirror, and this is according to the origin mirror. Okay, I hope you're able to understand what I was talking about. We're talking about mirror images. Okay, how mirror images are formed and with respect to what mirror images can become. Let's assume that they tell us, let's assume that they tell us, you please find out the mirror image of this point with respect to this line. Okay, this line is standing tall at, this line is standing tall at x being equal to 0, because, or x being equal to 5 and y being equal to infinity. So this is 5, this is 5 comma 0. Okay, this is where the line is standing. Okay, this is where the line is standing. If they ask me to find out the mirror image of this point, I would take it in the other direction and make the point over here and call this the mirror image of this particular point. This is the mirror, this is A and this is A dash. A dash is the mirror image of A. When we are talking about any particular line, not talking about the axes at all, or the axis, okay? When I say axis, I mean to say only one axis. When I say axis, then I mean to say there are multiple axes. There can be 2 dimensions, there can be 3 dimensions. Okay, good enough. Let's move ahead. Now, what is the reflection of the point 5 comma minus 3 in the line y equal to 3? In the line y equal to 3. Let me quickly draw the line y equal to 3. Okay, when I say y equal to 3, that means it must be somewhere here. 1, 2, 3. So here is my line, which is y equal to 3. This is the line y equal to 3. So now I need to have the point 5 comma minus 3. 5 is here, okay? 1, 2, 3, 4, 5, and minus 3 here. 1, 2, and 3. Minus 3 being equal to this place. So 5 comma minus 3 falls somewhere here. Okay, so this is 5 comma minus 3. This is 1, this is 2, this is 3, this is 1, this is minus 1, minus 2, and minus 3. So we have to find out the reflection of this point against this line. So what we'll do is we'll try to figure out first what is the distance between this line and this point. The distance between this line and this point. As clearly I can see that this is minus 3 units here. I can also see that this is plus 3 units here. So when I add up these units, I can say that the gap between them is 6 units. Now I have to extend myself more above the line y equal to 3. How much would I expand myself? I would expand myself 6 units more. So when I expand myself 6 units more, I get the coordinate as, we are only focusing on the y-axis right now. This is minus 3, this is 0, this is plus 3, plus 6 more, this would become plus 9. The x-axis would remain constant because we are not moving anywhere in the x-axis direction. So I have a plus 9 with me, which is the y coordinate, and the x coordinate is going to remain constant. That is why my answer is going to be 5 comma 9, or simply 5 comma plus 9. Okay, plus 5 plus 9. That is the reflection of the point with respect to the line y equal to 3. Good enough? Let me move on. Now, there can be situations when you'll be asked a little difficult questions, the ones which are a little maybe out of the syllabus as well. So this is one such instance when the equation of a circle was asked in the exam. So if I have a circle with me over here with center C, I'll draw my own circle with center at O, and I have a point. The coordinates of O are equal to A comma B. So using this I have to find out the equation of a circle. The equation of a circle would become x minus a plus y minus b equal to r square. R square is nothing but the radius of the circle. Radius of the circle. This question has appeared once in the examination. That is why we are picking up the same question again. Okay, good enough. Let's move on. Now, what is the equation of a circle with center of origin and radius as 6 centimeter square? We are at the same situation. The origin is O and 0 comma 0, or the origin is the coordinate, are the coordinates of the circle. And again, I have a circle. The radius that I have over here is equal to 6. I'll go back to my formula. I'll go back and see what is here. The question talks about, or the formula talks about x minus a, y minus b being equal to r square. Okay, x minus a whole square, y minus b whole square, both being added, they create my formula. Okay, they create my formula. So x minus a, when I talk about x minus a is the origin, so this would come out as 0. B is also my origin, so this would come out as 0. A and B are 0 because they lie on the origin, and the coordinates of the origin are 0 comma 0. So x minus 0 is nothing but x square, y minus 0 is nothing but y square, being equal to r square. R square is equal to 36. Okay, r square is equal to 36. So this is how we take things forward. Good. Let's move on. Let's move on. So now we will get situations in which we'll have to find out the area of the triangle. There is definitely a formula where we can apply half into base into height. This is not very unusual for all of you because this is this is the most standard formula of a right angle triangle. But in situations where the triangles are not right angle in nature, at that time we use the formulas S is equal to A plus B plus C, the semi-perimeter formula or the Heron's formula, which we popularly call it. And the area comes out as S into S minus A into S minus B into S minus C. Okay. Wherever I have put a dot, there is going to be a bracket around it. Okay. There is going to be a bracket around it. I'll quickly put it as well. So this would come out as another area of the triangle. This would come out as another area of the triangle. Got it? But Whenever we talk about coordinate geometry, we will have to play with the coordinates. We'll have to play with the coordinates of each side. So we have 3 points which have respective coordinates as x1, y1, x2, y2, x3, y3. So the area of the triangle would come out to be as x1 multiplied by y2 minus y3, x2 multiplied by y3 minus y1, and x3 being multiplied by y1 minus y2. So what is actually happening here? We are trying to maintain the series of 1, 2, 3, and we are putting it in the rolling order. What is the rolling order? We have 1, 2, 3 here. 1 rolls back. We have 2, 3, 1 here. 2 rolls back. We have 3, 1, 2 here. Okay, 1, 2, 3 in the rolling back order, with x being outside and y coordinates being subtracted from each other. X outside, y coordinates being subtracted from each other. Okay, so this is how the situation would move up. Good enough? Good enough? So this is it. This is it. Okay, let me move forward. Now, find the area of the triangle formed by points this, this, and this. So how would I proceed with it? I would have my P, Q, and R, x1, y1, x2, y2, x3, y3, minus 1.5, comma 3, 6, comma 6, and minus, sorry, this is minus 2, and minus 3 and 4. Minus 3 and 4. This might look like 9. This is 4. So I'll be solving them out now. So to solve them, I'll quickly write down the formula: x1, y2 minus y3, x2, y3 minus y1, and x3, y1 minus y2. Okay, all of them are multiplied. There would be a half sign which is staying outside, and there would be plus signs in the middle. Okay, there is going to be a half sign which is outside, and there would be a plus sign which is staying in the middle. Okay, I'll quickly write it down: minus 1.5 being multiplied by y2 minus y3, which is equal to minus 6. The minus 6 when multiplied by minus 1.5 would give me 15 6 are 90. So this is going to be a simple 9 here, with a plus sign, x2 being equal to 6, y3 minus y1. So this is going to be simply a 6, because y3 minus y1 is 1, plus x3 being minus 3 in nature, and minus 3 with y1 minus y2. So this would become a y1 minus y2. This would become a 5, and it would become a minus 15, if I'm not wrong. Yeah, this was a minus here, this was a minus here, y1 minus y2. Yeah, this has come out to be minus 15. But what do I get out of it? I get that the area of the triangle is coming out to be 0 in this situation. So it might be 0. It might be 0 because all the lines might not be reaching to or meeting together, or they might be parallel in nature. But the main focus is, I hope you're able to understand what was going on here. Okay, I hope you're able to understand what was going on here, how we calculated things, right? How we calculated things. So let me so yes, the area of the triangle is equal to 0. Whenever we get the area of triangle being equal to 0, okay, area of triangle being equal to 0, at that time we can declare that the points are collinear. When all the points are lying in a same line, at that time a triangle cannot be formed. Even if a triangle is formed, then we won't have any gaps. So that means there is no area. So this is another very good way to find out if the points are collinear or not. To find out the area of the triangle, if the area of the triangle is equal to 0, that means the points are collinear in nature. Okay, let's move on. Now, we have 4 vertices of a quadrilateral, and we need to find out the area of the quadrilateral. Okay, so I am not assuming, like I am assuming this, that all the points here are figured out randomly. Okay, so I have A, B, C and D. So A, B, C stand for minus 5 comma 7, minus 4 comma minus 5, minus 1 comma minus 6, and this is D. This isn't O, this is D. D is equal to 4 comma 5. Now there are ways to actually do it, but I'll be using the most simple method. I would first find out the area of the triangle ABC. I'll call this triangle 1, and then I'll find out the area of the triangle ADC. Okay, so these two areas of the triangle I'll find out, and then I'll simply add them up. I'll simply add them up, and then I'll find the final answer or the final area of the quadrilateral. So to do that, what I'll do is I'll write 1 over here and find out the area of the triangle. I have minus 5 comma 7. This is this and this. Okay, so minus 5 would remain inside. The other two, minus 5 and minus 6 means plus 6. That makes it 1. Plus, I would have a minus 4 here being multiplied by minus 6 and minus 7. That would make minus 13. Another plus, I would have a minus 1 over here, and 7 minus 5 is nothing but 12. So I have a minus 12. I have a minus 12. I have a plus 52. That makes it 40. Yeah, minus 12 and plus 52 make it 40, and 40 minus 5 make it 35. So the entire thing would also have a half on the outside. So 35 by 2 is the area of the triangle ABC. Okay, this is the area of the triangle ABC. Secondly, I'll try to find out the area of the triangle ADC. I'll try to find out the area of the triangle ADC. So for that, for ADC, I would first have a half outside. Then the minus 5 would stay here. 5 minus 6 is 11. So this would be multiplied by 11. I would have a plus sign. There would be 4 and minus 6 and minus 3. Sorry, minus 6 and minus 7. That would make a minus 13. It would stay here. Then I would have another plus minus 5. I have 11. Then I have a 4. Then would have a plus. A minus 1 would prevail here. Then 7 minus 5 is equal to 2. So I have 13 fours are 52. I have 13 fours are 52. I have a minus 52 here. I have a minus 55 here. And I have a minus 2 here. Okay. I have a minus 2 here. Also, this is 35 by 2. And so I would solve this up. There is one point which I have missed in the past. So here I can see that there is this parallel line. Okay, these are the vertical slabs. This is called basically the absolute sign. This is the absolute sign. This means that the area cannot be negative in nature. So here I was getting the area in negative. That's why I was a little worried. So this was the point which I missed. This is minus 55, minus 52 and minus 2. Minus 55, minus 52. This would make for 104 in negative. Yeah, this would make for 104 by, no, I'll just see one more time. I have 55, I have 52 and I have 2. This would make for 109. This would make for 109 upon 2. This is the area of the triangle ADC. My final answer is going to be the sum of 1 and 2, which is ABC plus ADC. That would make up the entire quadrilateral. This would become 144 upon 2, which is also equal to 72 square unit. Now this is the area of the quadrilateral. Okay, let's move on. This is one last miscellaneous question. This is actually picked up from linear equations, but linear or quadratic equations, but this would be a little interesting. Alpha and beta are two roots of the quadratic equation ax square minus bx plus c being equal to 0, where a, b and c are constants and a is not equal to 0. Then find the value of 1 upon a plus 1 upon b, or 1 upon alpha upon 1 upon beta. So we know from our experience that the sum of roots alpha plus beta, the sum of roots is equal to minus b by a, and the product of roots alpha into beta is equal to c by a. Okay, alpha plus beta and alpha into beta is c by a. When I talk about alpha plus beta, I need to find out 1 upon alpha plus 1 upon beta. If I say that alpha plus beta can wholly be divided by alpha beta, we would get 1 upon alpha plus 1 upon beta. When I separate them two, when I separate them both, at that time I can find 1 upon alpha plus 1 upon beta, right? So what I simply have to do is I have to simply divide minus b by a, and I have to divide it by c by a. So minus b by a into c upon a, the a and a would get cancelled, and minus b upon c is my answer. Okay, so this is where we end the situation of coordinate geometry. There's not much to learn, but there are some concepts to understand. You can learn the formulas of areas of the triangle. One major point which I missed out was centroid. Okay, centroid is a plus b plus c by 2, or x1 plus x2 plus x3 by 2, y1 plus y2 plus y3 by 2. Simple formula, you learn it. Most of the people remember this. Coordinate of incenter also. This is something which hasn't been asked yet, but you can learn the formula from here. Okay, there's not much application required as well. Equation of circle, yes, you may learn it. We've talked about reflections, we've talked about slope intercept form, simple intercept form, we've talked about section formula. Now there is also a situation in which we can find that it is lying on the midpoint. Okay, there is a situation where things might lie on the midpoint. Whenever things are lying on the midpoint, at that time the midpoint becomes x1 plus x2 whole by 2 and y1 plus y2 whole by 2. Whenever a line segment, whenever a line segment is divided in the middle, and it is asked what are the midpoints of the middle of any two points of or of any line segment, at that time we can say the midpoints are x1 plus x2 by 2 and y1 plus y2 by 2. As simple as that. Okay, so this is where we end coordinate geometry, and see you in the upcoming lectures.